Hi, I'm kim.bard. I have this short presentation on positive change for theories of social cognition. In a previous short video, I outlined 5 problems with studies that serve as the foundation for evolutionary and developmental theories of social cognition. And here, I'd like to present some ways to correct those design problems. These recommendations are based on the success of our new comparative design that we present in our monograph as a proof of concept. Developmental and evolutionary theories can be improved with the use of this new design to create new databases and to add to existing databases. And thus, theories of social cognition can be built on the foundation of inclusiveness. We propose these 4 steps towards achieving positive change in theories of social cognition. The aim is for evolutionary and developmental theories of social cognition to be more inclusive, and for studies to be able to isolate real differences between species, that is, differences over and above the variation that exists within each species. I'll briefly discuss each step in the next slides. So the first step is to decolonize our operational definitions, decolonize our samples, and therefore to have conclusions that are more inclusive. Becoming more inclusive essentially means to stop prioritizing Western, educated, industrialized, rich, and democratic samples, that is, weird samples, and to stop prioritizing weird results. To decolonize developmental science, we need to stop using these weird outcomes as the benchmark against which all other groups are compared. We need to work harder to reduce unconscious bias, to stop assuming that what we find in a weird sample is the norm or the gold standard. For more details on decolonizing as a process, please see the teaching resource that's on Monograph Matters, or of course the monograph. The second step in making positive change for theories of social cognition involves using multiple samples from diverse socioeconomic and cultural settings to capture species-level capacities, both for humans and for chimpanzees. For an overview of what we found about human infants' joint attentional capacities using this design, you may see our teaching resource on Monograph Matters, or of course, the monograph. With our monograph, we documented proof of concept demonstrating how to build a new inclusive database for comparative and developmental studies. For example, the left figure shows the high levels of joint engagement across all of our groups. This is the result that we found when we made our operational definitions of joint attention more inclusive, allowing for visual and non-visual forms of engagement, allowing for varieties of partners, allowing for diversity in the types of shared topics, and allowing for both positive, negative, and neutral emotional tones and initiations by either partner. In contrast, the figure on the right shows the results that we found when the operational definition is the joint attention phenotype, the type that is typically reported in primarily weird samples. And here we see it's significantly more prevalent in the UK than in the other human infant groups, and appears to be more prevalent in the chimpanzees raised in a weird setting than the other chimpanzee infant groups. So this definition we would say is biased, prioritizing a weird form of joint attention. Decolonizing our definitions and using multiple samples of human infants and chimpanzee infants, we find that triadic connectedness, represented in the graph on the left, is very common across 1-year-old chimpanzees and 1-year-old humans, with medians above 60%, and there's no significant difference across the settings or across the species. The way forward is to use multiple groups to include the diversity within the human species, and similarly to use multiple groups to include diversity within chimpanzee species. With this more inclusive view, we can learn how infants and partners engage together about shared topics, and learn that behavioral phenotypes of joint attention are highly contextualized for both species. To search for species differences in joint attention, we considered cross-species differences in each aspect of the 5 characteristics of joint engagement that we studied. Since we found that there was not a universal phenotype for humans, we needed to make comparisons with each human infant group separately. As you can see on the left-hand side, we've got our 3 samples. And since we didn't find a universal phenotype for chimpanzees, we have to compare the human infant groups with each chimpanzee infant group. So this table summarizes our cross-species comparisons by viewing whether the predominant form of each characteristic was different or the same in these cross-species comparisons. I admit this table is really hard to take in, so I've made a new table to summarize these findings. Here I summarize the previous table by listing the human groups that do not differ from the chimpanzee groups in their predominant forms of joint engagement. The predominant partner, for instance, of the Nassau and the Aka human infants is the same as in Gombe, but the predominant partner for the UK is different. For the PRI and zoo chimpanzees, the predominant partner is the same as the UK sample, and also for the 2 chimpanzee infants that were home raised. The point of these last 2 slides is to highlight that there are not species differences in these characteristics of joint engagement when multiple groups of each species are considered. And at least one human group is similar to at least one chimpanzee group in each of these 5 characteristics of joint engagement. So the 4th step is to revise or develop new theories based on the design that we used. So new theories of social cognition must consider the capacity for social cognition in both species, which is evident only when using multiple samples. We propose that triadic connectedness is universally present in human and chimpanzee infants. We propose that this core ability of triadic connectedness was shared by the common ancestors. Infants of both species share flexibility in their responsiveness to the demands of particular socio-ecological settings, showing contextualization of behavioral phenotypes. Joint attention is not uniquely human. So we argue that we need new evolutionary and developmental theories of social cognition, ones that are based on more inclusive foundations, ones that include the diversity such as what we observed, both within species and across different socio-ecological settings. We do not doubt that there are species differences in social cognition, but our studies provide strong support for the conclusion that the species differences do not reside in those joint attentional abilities commonly observed in human and chimpanzee infants. Species-level conclusions require broad foundations that are inclusive of universal capacities in humans to compare with the universal capacities of great apes. We eagerly await new studies that embrace diversity, upon which we can build new theories that are inclusive and really document evolutionary and developmental differences. Thank you. So this presentation was based on our monograph, which is available open access at this website.